Welcome to The Explainer, where we take on complex topics and turn them into simple, powerful stories.
So let's just dive right in. Have you ever built a model that worked great, right up until the moment it didn't? It's a super common frustration, isn't it? Well, today we're going to explore the entire journey a model takes, from just a promising experiment all the way to a reliable tool that actually delivers value out in the real world.
Okay, so this is what we're talking about, the modern MLOps challenge, taking a model from a notebook to production. Building the model itself, that's just the first step. The real challenge, what we call the MLOps challenge, is managing its entire life, making sure it stays effective and trustworthy long after you've built it.
Because look, that journey from a great idea to a reliable production model is just filled with these hidden, messy complexities. It can feel really chaotic. But what we're going to do today is map it all out. We're going to see how the right tools can take all that chaos and turn it into a process that's structured, repeatable, and way more transparent.
So first things first, we have to build on solid ground. A great model absolutely needs a great foundation. And that foundation, it really begins with just two things: reliable version data and super organized experiments.
And that brings us to our first tool, Delta Lake. Now, the easiest way to think about this is like a time machine for your data. Seriously. It's an open source layer that brings rock-solid reliability to your data lakes. It lets you do things like version your data and time travel back to older versions. This is absolutely critical when you need to reproduce an experiment perfectly, which, is essential for debugging and validation.
Okay, so if Delta Lake is the time machine for your data, then MLflow? Well, MLflow is like the model's official lab notebook. It's another open source platform, but this one is all about managing the entire machine learning lifecycle. It meticulously records every single detail, every parameter, every metric, and every model file for every single experiment you run.
And this really captures the whole point, right? The before versus after. Before, you've got lost parameters, results you can't reproduce, messy data, and of course, the classic, well, it worked on my machine. After, with these tools, everything is logged. You get perfect reproducibility. Your data is nicely versioned with Delta, and all your runs are organized and searchable. We're moving from total chaos to complete clarity.
And what's so powerful here is just how simple this can be. We're not talking about a massive rewrite. With just a few lines of MLflow code, start the run, log the parameter, log the metric, every single part of your experiment gets logged. Your settings, your results, even the model file itself. It transforms it from a one-off attempt into a repeatable recipe that anyone on your team can run.
All right, let's move on. We've run our experiments and we've found a good one. Now it's time to graduate that model. This is the stage where a model stops being just some file sitting on a laptop and transforms into a real, reliable, versioned asset for the entire organization. And this brings us to a really key concept in MLflow, called the PyFunk flavor. This is brilliant. It doesn't just save the model weights. It packages up the entire prediction logic, including all your pre-processing steps, into one standard format. This makes the model super easy to deploy, and more importantly, it's a huge step in preventing that nasty problem we call training serving skew.
I love this quote. The model registry is where a model gets its resume and diploma. That really says it all, doesn't it? This is the central source of truth. It's where a model officially stops being just a simple experiment and becomes a governed version asset that's ready for the real world.
And this journey has clear, structured steps. A promising model gets registered, then it has to move to staging, where it gets put through its paces with a ton of validation. Only after it passes all those tests can it get promoted to production. This whole workflow is designed to ensure that only the best, highest quality models ever make it in front of your users.
So let's break down these stages. Each one has a really clear purpose. None is just the default starting point. Staging is the proving ground. This is where you do all your testing. Production? Well, that's showtime. And archived is for when a model is retired. It's a formal handoff process, a clear line of communication between data science and the operations teams. Okay, so our model has officially graduated with honors. It's time for its first day on the job. So let's talk about putting models to work and look at the different deployment strategies we have. And this brings us to a really important decision: batch versus real-time. It's all about choosing the right tool for the job. Real-time serving is absolutely essential for things like fraud detection, where you need an answer right now. But honestly, a lot of use cases are perfectly served by the simpler, much more cost-effective batch deployment.
And here's how that batch process typically works at scale. You load your production model right from the registry. You read in a huge data set from a delta table. Then you use something like a Spark UDF to apply that model across a whole cluster in parallel. What's so cool about this is that even a model you trained on a single laptop can now score massive data sets by leveraging the power of distributed computing.
But for those moments when you need an answer immediately, that's when we turn to real-time serving. The model gets deployed to what's called a model serving endpoint. Basically, it's ready and waiting to respond to API requests in just a few milliseconds.
All right, the model is deployed. Job done, right? Nope, not even close. A model's job isn't over once it's deployed. In a way, it's just beginning. We have to keep our models healthy, and that means giving them regular checkups to monitor for any drift.
And this is the really big question you have to keep asking. The world changes. Is your model changing with it? Because the real world is constantly shifting, but a trained model is static. It's a snapshot in time. And over time, its performance can just silently degrade because of this thing we call drift. And it's important to understand the two main types of drift. First, you have feature drift. This is pretty straightforward. These statistical properties of your input data change. Think, like the average age of your customers suddenly shifts. Then there's concept drift, which is way more subtle. This is when the relationship between the inputs and the output changes. What used to predict churn last year just doesn't anymore.
And here's a super clear example of that feature drift. Look at this chart. The model was trained on data where the average purchase value was about 50. But now in Q4, the production data shows an average value closer to 85. The model is seeing data it wasn't prepared for. That's a classic case of feature drift, and it's almost guaranteed to mess with your predictions.
So how do you actually monitor for this stuff? Well, the best practice is a layered approach. You can start with simple checks. Just monitor basic stats like mean, median, and so on. If those start to look weird, you can escalate to more robust statistical tests, like a KS test for numbers or a chi-square for categories. But at the end of the day, the ultimate sign of drift is tracking the model's actual performance. A dip in accuracy is the final word.
So what's the solution when you find drift? It's pretty simple, actually. The whole cycle just begins again. You monitor, you retrain the model on new, fresh data, you validate that new version, and then you redeploy it. It's this continuous cycle that ensures your model stays aligned with reality. Which brings us to our final and maybe most important question. Your model is in production, but is it still the same model you trained? This question right here is the absolute core of MLOps. It's that constant reminder that a model isn't just a project you finish, it's a living asset that needs continuous care and attention if it's going to stay valuable.